Hello, and welcome to the second episode of the Atherosclerosis podcast, a podcast run by the AES Young Fellows. My name is Pelin Golforoush, and I'm representing the Hatha Cardiovascular Institute at UCL in London, and I will be your host for today's episode. In this series of interviews with experts, we're joined today by Professor Katey Rayner at the European Lipoprotein Club meeting in Tutzing, Germany. Professor Rayner is the Chief Scientific Officer and Vice President of Research at the Heart Institute at the University of Ottawa, as well as the Director of the Vascular Inflammation and Metabolism Laboratory. Her groundbreaking research has contributed to understanding the interplay between inflammation, lipid metabolism, and cardiovascular disease, opening new avenues for the development of RNA-based therapeutic approaches. Hello, Professor Katey Rayner. We are thrilled to have you here today to discuss your trajectory and your impressions on the current atherosclerosis research. On behalf of the AES Young Fellows, I would like to thank you for accepting this invitation. In this interview, we want our listeners to get to know more about you and your research. Could you please first introduce yourself to our listeners?
Absolutely. My name is Katey Rayner, and I'm a professor at the University of Ottawa Heart Institute, where I run a large and active research lab studying atherosclerosis and inflammation. And I'm also the chief scientific officer there as well, of the Heart Institute. So that means I sort of direct and help enable all of the research that happens at the Ottawa Heart Institute.
Yeah. Thank you very much for that introduction. So before asking you academic-related questions, we would like to ask you to kind of talk about your personal life. Mm-hmm. Could you describe to us what a typical day in your life looks like?
Well, I have a fantastic family. I've got two relatively young kids. They're 10 and 13, and a great husband. And so a typical day begins really with them, and it's about getting them off to school and getting them just what they need. And, you know, they're independent and amazing, but of course they still need lots of pushing and prodding to make sure they get out the door. I'm usually now in the post-COVID world, there's a lot of virtual meetings. So it's great actually, because it means I can take a meeting about, you know, this, that, or the other at home while I'm also getting my kids ready for school. So that usually starts kind of a little bit of both. I spend a lot of my time physically in the lab. I don't do experiments anymore, but I'm right nearby with my group. But of course, that means a combination mostly of meeting and talking about the work as opposed to me doing it anymore. I'm long out of doing the actual experiments. But and then I might have meetings about, you know, I do a lot of collaborative work with people. So we have large group projects that are sort of, you know, multi PI. So we'll end up having, you know, a monthly meeting about some project or another, or I supervise a lot of students as well. And so that means there's thesis advisory committees and there's, you know, defenses and these kinds of things as well. So, you know, in a typical day, I'd have, you know, one of those. My kids are both active hockey players. And so it means that I'm often running to a rink after the lab at the end of the day, particularly, you know, I'm in Canada, of course, so in the winter months, which there are many. So it typically ends with me in a cold hockey rink in one way or another. So that's a fairly typical day for me.
Okay, so leadership qualities required both at home and at work. That's
right.
Great. So do you miss working in the lab then, now that you're out of it?
It's funny you say that. I do. I really do. But at the same time, I became a very bad experimentalist almost immediately becoming a PI, because you do have these random meetings and you do have these things that you have to think about, and your brain has to be in two places at once. And so I found, you know, I'd truly forget about the experiments I was running. And I had been a meticulous experimentalist before that. And suddenly when I'd have a meeting that ran over and that would, you know, ruin my experiment, or I'd be, you know, down doing something with, you know, mice or animals. And then all of a sudden I'd miss a meeting, you know, so I sort of found very quickly that I can't do both. The part about the lab I miss probably the most is the hands-on training with the new students. Of course, that's because I don't do anything in the lab anymore. It's passed on to other people. So I'd say that's part of I think that specifically is what I miss the most.
Yeah. I think it's also rewarding for you
It
to
is.
obviously work with your students, right?
It is. But at the same time, now what I realize is that because I have a group of people doing, the work that we're all kind of conceiving together, it feels like I have a million hands. So instead of me just doing my experiment and, oh, it didn't work, or it did work, and it was all sort of about you and what you did, now I get to do that, but it's multiplied with so many others that I feel, I get rewarded for their hard work.
Yeah, yeah. So how would you spend your free time going a bit away from the lab now? Do you have any hobbies?
I will admit I'm not a great hobbyist. I remember saying at some point, probably not long after I'd started my lab, that my hobby was PubMed, because I would find myself down these rabbit holes when I was thinking about a project, and I enjoyed doing it. I really loved diving into something. You have an idea or you have a piece of data and you want to think about it. But I realized that was sort of not really that healthy or well-rounded overall. So I've tried a little bit more in the last few years. So I've decided, exercise can be an indirect hobby. So, I took up running a number of years ago. I did my first triathlon last year, actually. Nice. So that, that involved learning how to swim in a way that isn't just flopping around in a pool or things like that. And so, although, again, not really explicitly hobbies, it's something to do outside of work. And then it makes it a little bit more fun because a lot of the activities I do with good friends. And so it's a way to connect socially, decompress. It's good for your body. It's good for your mental health. So, not maybe, maybe I'm on my way to eventual hobbies, but for now, exercise will do.
Yeah, congratulations. I know it's tough. It's tough to do. What do you aim to achieve personally in the next few years?
On a personal level, at this age of my kids, I'm hoping that they are, as they get a little older, that, they're happy and healthy, right? I want them to be doing things that they love. I want them to be succeeding in school. So, I don't have anything specific that I would like to accomplish in the next few years that doesn't involve sort of my family. I will say, we haven't traveled a lot as a family. We went on a big trip this past summer. So if I can, wrangle some sort of amazing adventure somewhere very cool with everybody in my family, I think I will consider that a success, because, to be honest, I think that's a challenge. And for me, a lot of my personal goals really they're focused on my work. So I think, I've recently been appointed this really exciting position as Chief Scientific Officer. So I think that's going to be where I'm going to really focus my excitement and my enthusiasm, is, trying to help people and help elevate the research that we're doing at the Institute, to another level, and to get people kind of where they want to go and where they see their research going, and kind of being able to direct them there.
Yeah, I really like your answers because they involve life and work. So speaking of the holiday, did you plan where to go yet, or do you have any ideas?
So I had this relatively short trip to Hawaii a number of years ago, and I absolutely fell in love with it. And so I would absolutely love to go, and maybe not Hawaii again, but maybe somewhere like Hawaii, just like islands and interesting, plants and animals. I recently got into birding. I'm a bad birder. I can't tell anything without the app telling me what's singing at me or what that looks like. But I find birds oddly fascinating, and so I find myself, wanting to go places where there's going to be cool birds, like maybe Costa Rica or something like that. So those are those are on my hit list.
That sounds amazing. Well, I hope you have fun. So now going on to academic experiences, could you tell us about your academic journey? Like, for example, what have you studied? What were some of the key decisions or turning points that shaped your career path?
Yeah, so I don't have a very interesting beginning of the journey. I kind of was decently good at sciences and math, and so I just sort of went in that direction. I turned out I really liked the human body. I mean, despite what I just said about birds, I really liked the human body and how it worked, as opposed to sort of plants and animals, that kind of thing. So I went sort of in the human sciences. And I discovered that research was a career really late in university. I had no idea there were such things as sort of research labs working in diseases and problems like that. So that really, really struck me. And I'd say the turning point in my career, I can absolutely nail it. It's when I met my eventual postdoc supervisor. So So I was finishing my PhD, as many PhD students struggle with. What am I going to do next? What do I want to be? Okay, I think I want to do a postdoc. Where do I want to go? What do I want to study? And I'd gone to a conference kind of with the goal to really meet somebody and see if I could kind of just see what's out there. And I met this woman, and her name is Catherine Moore. And I'd never had a woman at that level. Like, I'd never really met a scientist at this. She was so famous, everybody knew her. And I met her, and she was just so genuine and so nice and so inviting and easy to talk to, which I thought was so incredible. And then, and then she mentioned, her 3-year-old and her, 6-month-old at home. And I'm going, are you serious? Like, she was at Harvard, how do you do all of this? But she very enthusiastically invited me to come to give a talk at the lab and meet everybody and consider a postdoc, which I did. And that was it. That sealed the deal. And her and I have been, we had a terrific experience in her lab. I mean, 10 on 10. There's absolutely nothing that could have been done better. She made me the scientist I am. And of course, all my mentors have made me the scientist that I am. But, that meeting her, seeing someone, air quotes, do it all, and do it with grace and be genuine and be real and be normal, really, really completely changed, I think, how I became an eventual, the type of scientist I became. And, we work together still. We talk all the time. It turned from mentorship into friendship. And, but yeah, if I hadn't have met her at that conference that time, I honestly don't know what path I'd be on.
It's funny how life works like that, right?
Yep.
And it's really important to actually have mentors who will encourage you further. I think we need to emphasize that luck is involved as well in this, isn't it? So you need to be lucky about who you meet and where you meet.
Yeah, I mean, I a lot of people use the word luck, and I like to turn it a little bit. And people have heard this statement probably: "You've got to be good to be lucky."
Yeah.
Or I think it's a Louis Pasteur quote that's "Chance favors the prepared mind." So yes, there's luck, there's serendipity everywhere we go, but at the same time, you have to be ready for it. Because if you're not ready for it, if you're not aware of what you're doing in the surroundings, luck will 100%, those lucky moments will pass you by. So yes, I think all of us can think of examples, but we were there for a reason. We in this scenario, I was there because I was looking for the next opportunity, and then I found it. So, we take ourselves out of the equation when we say luck, and we don't account for all the work you put into it, right? And so you got to be good to be lucky is or again, it's a little bit nicer to say chance favors the prepared mind, but yeah,
that's true. You need to be open to grabbing the opportunities that come.
You got to be watching for them. Yeah.
So on your lab website, you're described as the fearless leader. A fearless person tends to also take a lot of risks that are essential in making significant advancements. So can you share a time when you took a risk in your research career, and what was the outcome?
Yeah, so I'd say that the risks that I take are that I think fundamentally we need to, ask the research question that we're interested in. We just have to ask it. We just have to try it. If we think about things too much, we'll usually think ourselves into paralysis. We think, well, it won't work. Oh, well, it's really hard, and that kind of thing. And so I think some of the risks I took were the work that I presented a little bit today was about this, this at the time relatively newly discovered form of cell death called necroptosis. And there weren't a lot of tools. There weren't a lot of things to study it. People were out there doing it, but I really, I fundamentally believed that this was something that was probably happening in the atherosclerotic plaque, and I just really needed to know. It was a complete deviation from what I had established my lab doing. We were studying microRNAs and, HDL cholesterol and cholesterol efflux. We weren't doing anything with cell death and anything, And although it doesn't sound risky, but when you're a new PI and you're really just trying to establish yourself, it kind of is a little bit of a leap. And so, but you have to take it, because otherwise, 10 years later, you're just looking around going, oh, I could have done that, right? So I'd say that the reason that sometimes, they call me the fearless leader sometimes is that, I'm not afraid to just say, let's just do it. Let's just do it. Because it really, you have to know, you have to test it to know. And if we don't do that, we're always just left looking at each other kind of, well, yeah, I don't know, maybe, right? So, and I think that's the type of scientist I am. I don't mind taking risks. Sometimes they don't work out. Sometimes, there's absolutely nothing in the study. The study is completely null, but you had to ask, you had to find out. So
yeah, sometimes change is definitely necessary.
Yep.
And actually, when you think out of the box, that's when the best discoveries are made.
Exactly. Yep.
So in our interview series, we have a section dedicated to failures, and we call this the graveyard of ideas. Most of the time, we only hear success stories of other researchers, which sometimes makes us question ourselves, whether we're good enough or not. And we want all researchers, especially younger researchers, to know that failure is part of the process. So we decided to ask everyone in this series of interviews to contribute an idea to our graveyard of ideas. So do you have such an idea?
Yeah, I have a number of them. I mean, I think that you're right. There's so much that's emphasizing, positive bias, right? So the things that worked, quote unquote, end up in the study, in the presentation, in the thesis, whatever. But it doesn't, not a lot of it talks about things that doesn't. One of the things that I really got very, very, very excited about a number of years ago was ApoA1, which, as we know, is a very important protein for cholesterol efflux, for HDL, those kinds of things, which is, again, how I started my lab. We were studying macrophages, and we saw that they were expressing ApoA1, and we thought, that's funny. They're not supposed to express ApoA1. They're supposed to, it's supposed to be made by the liver. So I got really excited, and I thought, oh my God, I think I've just discovered that this tissue doesn't. That's crazy, right? And so I had this postdoc who had just started in the lab, and he was kind of learning different things. And I said, you have to look at this. I think macrophages. So we did all these different experiments, and sure enough, these macrophages kept expressing ApoA1, and I could see this. This major breakthrough that we just discovered, right? Yeah. And so then a collaborator sent us some macrophages from ApoA1 knockout mice. And by the way, this collaborator was like, I don't think this is true. Like, I don't think you're. I was like, no, believe me, I think I've discovered something major. So she, graciously sent me these knockout cells, but lo and behold, they also expressed ApoA1. And I of course think, oh, well, they've misidentified their mice. They're not knockout mice, So I called them, and she's like, no, So it was just coming from the cell culture media. It was just the cell culture media. There's tons of, lipoproteins in your cell culture media, and guess what? When you blot for them, sometimes they end up in, right? So, I mean, that's kind of a comical failure. And I mean, I didn't, necessarily, it wasn't this big, but it's an example of how, you can be really sure of something and actually even do the experiment in a way that you think you've covered all the bases. And so, but then the last experiment, obviously, is the one that tells you, oh, no, you've missed something really big and really important. And this is how, why the importance of positive and negative control. So, but I'd say that, there's almost every one of our studies, out of all the hypotheses, because we try different things, we never look at just one angle. We never say, this is it, and that's what we're going for. Always we find the pathway that is not at all related to what you're studying. So there's no question. And we do try to put those often in the studies that we publish, because they they're important too, because somebody else is out there potentially thinking the same thing. And if they can go back to your work and say, oh, I see, they've already tested that, then it maybe saves somebody a tiny little bit of heartache.
Exactly. I think negative results is really important to publish as well.
Always.
Unfortunately, sometimes journals aren't really happy to publish.
Yeah, I mean, it's not as hot, right? It doesn't sound as great to say that this is not what's involved, but it is still important to share with each other, for sure.
At least you found out the reason why.
Yeah. We didn't just publish it. That's true. We discovered this, No, we didn't.
So when you think about the legacy you want to leave behind in your field, what do you hope your most significant contribution will be?
I think, I suppose my first answer will be the legacy that I leave on my trainees. Number one, I couldn't care less if we discover mediocre science only. If they're doing well, and if they're having a positive experience and they're learning how to do important research in a good way. That's all I care about. And that's the number one thing. If I'm thinking more specifically about the field and kind of, I do think of any science, but particularly sort of preclinical, biomedical, mechanistic science as a giant human chain. Like we're all linked arms and we're all just kind of, 1, 2, 3, getting the field forward. So I'm happy if any of my discoveries are part of that human chain. But truthfully, I still get very frustrated at the idea that heart attacks are something that we know really, really well how to prevent, really well. A lot of patients who are at the most risk don't seem to take the advice that is given to them. And I probably include myself as one of them, right? I mean, I know a bunch of things that I do that are sort of, not as healthy as they could be. And yet I do them. So, something that I've always been really interested in is to develop some kind of diagnostic. I think risk is something arbitrary that people are not great at assuming, but I think if there's a better way, we can really diagnose the existence of the level of plaque that we really think is going to cause a heart attack somewhat imminently. I think that hits home a little bit harder. So we're getting closer, as we know. Imaging is really getting us closer and closer to that. And I think, some of the work we're doing, we're trying to pair it with molecular imaging so that once we identify something, interesting and funny happening in the vessel wall, maybe we can develop a tracer to detect it. And is that something that can maybe tell us that there's, advanced disease or, disease likely to cause a heart attack? So that's kind of, I guess, pie in the sky dream that I would love if our research led to something like that.
Yeah. Speaking of your legacy, passing on the torch to the younger scientists. Mm-hmm. So we want to ask you whether you have any open positions in your lab, because some may want to apply for internships, some may want to do their PhD or postdoc positions with you. Do you have any available positions at your institute at the moment that you'd like to announce?
So actually I don't tend to have, I don't have like seasons or times or, precise things happening where I have always an open position, in next summer or next year or something like that. However, I did just today submit a grant proposal, and it's actually studying RNA and inflammation. And if I say it is just so cool. So should that be funded, and I will know, kind of early next year, I will have absolutely new positions in that case, because it's a very new, separate project that will just be starting. And I think there's a lot of opportunity. Yeah, you know what? Our institute, we have a lot of different kinds of cardiovascular science, all the way from, really, pure clinical research, all the way to the most basic, beating heart cells in a dish kind of research. And almost always someone in there is looking for particularly PhD and postdocs. We have loads of master's programs in Canada too. So of course it's difficult depending on, where you're listening from, sometimes to, as an international student, but certainly postdocs are easy. And we certainly always welcome applications. And I would say to people, a lot of times people don't necessarily have the opportunity to advertise. They might eventually advertise, but they may have just heard that they're awarded funding, or a collaborator reaches out to them with a cool project, and maybe they're sort of not organized enough yet to fully advertise. So I would say introduce yourself, make contact, and just have that conversation about, maybe somewhere in the future there might be an opportunity. When I looked for my postdoc position, I was a year in advance of ending my before I finished my PhD, and it was more just giving some time. You never know. Somebody else might be leaving. Somebody else might be wanting to join. So it's good to plan in advance, but contact people anyways, even if they don't have an explicit, and myself included.
Yeah. Firstly, good luck with the grant application.
Thank you.
So fingers crossed for that. And so is there a platform that our listeners could check for these open positions? You said other groups may also be looking for.
Yeah, I'd say that, our Heart Institute website, so the Ottawa Heart Institute website, does advertise our positions there. And, sometimes it can be difficult, but, we do use Twitter a lot still. So most of us will end up having our Twitter account that we repost all, everyone else's advertising too. So I would check there as well.
Okay, thank you very much for sharing that. This was such an incredible interview. Thank you so much, Professor Katey Rayner, for sharing your time and insights with us. Also, big thank you to all our listeners. This podcast is for you, and we need your feedback to tailor it to your interests. So please don't forget to leave us your impressions or suggest topics. that you would like to hear more about. Again, thank you so much, Professor Rayner, and stay tuned for upcoming episodes.
Thank you.